Good morning Year 6 and welcome to today's arithmetic tutorial. So as always I'm going to start by going through the lower key stage questions and then I'll move on to the Year 5 and 6 questions. It might be useful to have a pen or paper ready as we go through the answers, or even to have sort of done your answers and then we can mark them together like we would normally in class. It's also really helpful if you can send your learning to me on Dojo, and that way I can give you some feedback and support you if you found anything tricky. Okay, let's get started. So we are going to start with question 1 of the lower key stage questions. 300 multiplied by 200. Now when we've been doing these at school, we've been ignoring the zeros. So in this case, we're making the numbers 100 times smaller. And we're going to be thinking about 3 times 2. So all I've done there is I've made the number 100 times smaller, or sort of ignored the zeros as we've been saying at school. 3 times 2 is 6. Then those zeros that I've ignored, I've got to put back on the end to make sure that I'm now putting my number up into the 10,000s. So I ignored 4 zeros at the start. I've got to put 4 zeros on the end to ensure now that I'm in the 10,000s. So we've got 60,000 as our answer. Okay, let's move on to question 2 then. We've got minus 15 or negative 15, add 21 equals. Now, I'm going to just draw your attention to the add symbol here. That means our answer needs to be bigger than negative 15. And we know that to increase the size of a negative number, I need to move towards 0. Okay, so when I'm adding, I'm moving towards 0. And you'll see I've drawn a number line here to help us. I know that if I'm starting at negative 15, and I add 15, that's going to take me to 0. Now I need to add 21 in total, so how much have I got left to add? Well, I could count on 16, 17, 18, 19, 20, 21 to know that I need to add another 6, and that would take me to positive 6, 0, add 6 is 6. Okay, so our answer for number 2 is 6. Let's have a look at number 3 then. Let's rub that black line out so we can see it clearly. On to number 3, 8 times 6. Now, if you don't feel very confident with your tables, you can always draw an array to help you. And so we're doing 8 lots of 6. So if I look at my first row here, I've got 1, 2, 3, 4, 5, 6, 7, 8. So I've got 1 lot of 8. And I want 6 lots of 8. So I've got 1 lot, 2 lots, 3 lots, 4 lots, 5 lots, and 6 lots of 8. And then, and Year 6, remember at home you can draw these or you can create them with bits of rice or pasta, or if you've got buttons at home or marbles, you might have lots of cars or bits of Lego. They're quite easy to create at home if you can sort of rummage around and find some resources. So then we would count all our marbles up or our bits of pasta, and we'd know that 8 times 6 or 6 times 8 is 48. Now, we also might be able to sort of work this out using some facts that we already know. So, for example, you might already know that 8 multiplied by 3 is 24. And you could use that to help you solve 8 multiplied by 6. If you can see here, I've double 3 is 6. So therefore, if I was to double 24, which is quite easy to do, double 20 is 40, and double 4 is 8, 48. Alternatively, you might know 5 times 8, we feel confident with our 5 times table. 5 times 8 is 40, and you could then use that to solve 6 times 8 is 48. Now, we know that multiplication is commutative, so whether I've written 8 times 4 or 6 times 8, it's still going to give us the same answer. And what all commutative means is that I can write the digits in any order and I would get the same answer. So I started with 8 here, 8 times 6 or 6 times 8. They give the same answer. Okay, let's have a look at question number 4 then. We've got something equals 372 subtract 8. Now we know the equals sign means the same as. So this side has to equal the same as this side of our calculation. So let's start by working out this side. 372 subtract 8. And again, I've got a number line here to help us. Now, let's look at this number here, 372. Well, I know that I could subtract 2 quite easily from this number because it would leave me with 370. That's just from looking at the ones column, I can do that. Now I actually want to subtract 8, which means if I've already subtracted 2, I've only got 6 left to subtract. And again, I can subtract 6 from this number really easily. I could count on my fingers backwards, or I could draw some little marks on my number line here to help me and count back. 6, and we get to 364. Okay, let's have a look then at question number 5. We've got 74 multiplied by 2. Now, if you're multiplying by 2, that's the same as doubling. So we want double 74. Okay, oh gosh, my handwriting's gone a little wonky there. So double 74. Now, some people might feel confident enough to do this in their heads or with a few jottings. So if I think about 70 to begin with, I'm just going to focus on my tens first of all. 70 times 2, or doubled, is 140. Then I can think about my ones. So 4 multiplied by 2 is 8. And I can add those together really quite quickly, 148. So some people may have done that mentally with a few jottings. Some people may have felt more confident to do the column method, which I'm just setting up over here for us. 4 multiplied by 2 is 8, and 7 multiplied by 2 is 14. 148. Right, let's have a look at our flashback then. Okay, the first question says, find the difference between 387 and 125. So what's the key words in this question? Great work, everybody. We've got to find the difference between these two numbers. Now, what does difference mean? What calculation are you being asked to do? Well, remember, difference is a subtraction or a takeaway. Now, I've done a column method here. So I've put my largest number on the top, put my subtraction symbol, I've got my smallest number on the bottom. I've checked my ones and my tens and my hundreds are in line, and I used a ruler to draw my lines at the bottom. So we start with our ones. We always start on the left in our ones. 7 subtract 5 is 2. 8 subtract 2 is 6. And 3 subtract 1 is 2. Okay, so if you've got 262 for that one, you can give it a neat little tick. Right, let's have a look then at the next question. We've got to calculate or solve 780, add 470. Now, I think most people have probably used either a mental method with some jottings or the column method. So we can do this one together. 0 add 0 is 0. 8 add 7 is 15, and you'll notice I'm pausing year 6 just to give you a chance to work out these with me as we go through. 7 add 4, add 1 is 12. Great job. 1,250. Okay, question 3 then. What is 1,000 more than 3,000? Okay, let's think about what's the key information in this question. So we want to know what is 1,000 more than 3,000. I'm going to do a jotting over here. I've got 3,000. Okay, and I want to know what 1,000 more is. Now, if I'm adding 1,000, it's the thousands column in my number that I'm interested in. So which digit is in the thousands column? Or which digit represents the thousands in this number? Hopefully you're sort of thinking to yourself, 3. If you weren't sure, then you could draw yourself a place value chart at home. And we're really used to drawing these, aren't we, year 6? Okay, we can identify that 3 represents the thousands. We've got 3,000 in this number. Now I want to add 1,000 more to this. So 3,000 add 1,000 is 4,000. I've got no hundreds, no tens or ones to add on, so they will stay the same. Okay, let's have a look then at this triangle. And children in this group at school, we haven't done a huge amount of angles this year. We did some work on angles in year 5, but this is definitely a sort of flashback to our learning from quite a little while ago. So don't worry if you haven't remembered this, we can go through it together now. It says complete the sentence, so that just means finish the sentence, to describe the triangle. The triangle has one something angle and two something angles. Okay, well let's have a look at the one angle first. Now we've got one here, these two. Okay, do you know the name of this triangle, year 6? Can you remember what we'd call this triangle? Okay, hopefully you've thought to yourself then that this is a right angle triangle, because you've noticed this angle in the corner here is at 90 degrees, and this symbol, this sort of small square, represents a right angle. We know a right angle is 90 degrees. So the triangle has one, I'm going to try and fit it in there as best I can, one right angle, okay, and two something angles. So that leaves us looking at these angles here. Now, what do we know about these angles? If we know this is a right angle, I've drawn it as best I can there, so we've got a right angle. Are these angles bigger or smaller than a right angle? What do you think, year 6? You're absolutely right. They are less than 90 degrees. They are smaller than a right angle. What do we call angles that are smaller than 90 degrees or less than 90 degrees? Can you remember? It begins with an A. They're less than or smaller than 90 degrees. They're called acute angles. So this triangle has two acute angles. I'm not sure I'm going to fit it in there. Let's see how I get on. Oh, just about. There we go. Now, for some of you who want to stretch your thinking a little bit and challenge yourself, can you remember how many degrees an angle has? A right angle triangle has in total? So, if I was to add these three angles up, what would it total? You're well remembered, everybody. Angles in triangles total 180 degrees. So if this one is 90 degrees, what could be the size of these angles? I'm going to ask you to send me your answers to me on Class Dojo, and I'll see how you get on. Remember, that's for those people who'd like a little bit of a challenge today and to stretch their thinking. Okay, let's move on then to the year 5 and 6 questions. We're going to start with question 1, which is 5/9 multiplied by 360. Okay, now remember that when we're thinking about multiplying by a whole number, this is the whole. Okay, and because it's out of the whole, one whole, we can put 1 on the bottom as our denominator to represent the one whole. And that's going to help us with our multiplication, because you know how to multiply fractions. You know, first of all, that we have to multiply the numerators or the top numbers. So we're going to do 5 multiplied by 360. Now, if you're not sure how to do that, you can do a little jotting. There's nothing wrong with doing a little jotting to work it out. Some of you might be able to do that mentally or use some of your known multiplication facts. If you can't, it's absolutely fine to do jottings. 0 multiplied by 5 is 0. 6 times 5 is 30, well done. And 3 times 5 is 15, brilliant. Add the 3 we've carried, 18. Okay, so we know our numerator then is 1,800. Okay, I'm going to rub those jottings out for us, so if you need to use them now, just pause the video. Right, so that takes us then onto our denominator, that bottom number. And again, we're multiplying fractions now, so we can do 9 multiplied by 1, which is 9. Okay, year 6, so you've got an answer there. Just have a careful look at that fraction. Are you happy with it? What do you know about that fraction? Well done to all those people who are thinking, oh, I know, it's an improper fraction. Okay, so the top number, that numerator, is bigger than the denominator. So we need to simplify this fraction. We need to put it in its smallest or simplest form. And to do that, we need to divide. We're going to see how many times does 9 go into 1,800. Again, if you need to do a jotting for this, you can. If you're somebody who feels a little bit more confident with some jottings, 9 into 1 doesn't go, so we carry the 1 over. 9 into 18 goes twice. 9 into 0 doesn't go. 9 into 0 doesn't go. So we've got an answer then of 200. Now, some of you may have been able to do that last calculation mentally. So let's have a look at how you do that. Let me just pop it up here so we've got a fresh working space. Remember, we're doing 9 into 1,800. Now, if I was to ignore the zeros here, I know 9 goes into 18 twice, and then the zeros that I ignore, I put back on. So that's a quick mental way of doing your division. Okay, let's have a look then at question 2. 1/6 multiplied by a half. Okay, 1/6 multiplied by 1/2. So just have a little think to yourself, year 6. How do we multiply fractions? What's our steps to success? You're absolutely right. We're going to start with the numerators. 1 multiplied by 1 is 1. And 6 multiplied by 2 is 12. And that fraction is in its simplest form. So we've got our answer there nice and quickly. 1/12. Okay, we're going to go on to question 3 then. We've got 463,257 add 58,916. And grown-ups at home, I'm going to go quite quickly through this one because I know the children are really confident with these. So I've got my largest number on the top. I've made sure that my ones, tens, hundreds, thousands and so on are all lined up carefully with each other. And I've used a ruler to draw my lines ready for my addition. So 7 add 6 is, and again you'll notice year 6 I'm pausing just to give you time to work it out alongside me if you need to. 5 add 1 add 1, 7. 2 add 9, 11. 3 add 8, add the 1 you've carried, is 12. And then 6, 5 and 1. Well, I know 5 and 1 is 6. And I know to add another 6 is 12. 4 and 1 is 5. Okay, well done to everybody who got that one correct. I'm not going to spend too long on that one because we've done that lots at school. Right, let's move on then to question 4. I know some of you might be feeling a little bit nervous about this one, but there's absolutely no need to, okay? I know you can do these. Okay, I have every faith in you that you can do this and be really successful. So let's do it together. Right, I've set up then my bus stop method here. So I've got 63.52 inside my bus stop and my divider or my divisor on the outside, 8. Now, if you're not very confident at your 8 times table, what I recommend you do is you write them out just on the side, you jot them down to help you. And you check really carefully that you've done that accurately so you don't make any mistakes. Okay, if you need to pause the video to do that, year 6, now's a good time. Okay, let's have a look together then. So I'm dividing 8 by 6. So how many times does 8 go into 6? Well, it doesn't. Okay, it's not. So I'm going to carry the 6 over. 8 into 63. So this is where I can use my multiples. How close can I get to 63? 56, well 64 I've gone past. So 56 is as close as I can get. So how many times does 8 go in equally? 1, 2, 3, 4, 5, 6, 7 times. But that only took me to 56 and I wanted to get as close to 63 as possible. So I've got some remainders. Now to work those out, I just count on from 56 to 63. Now you might be able to do that mentally or you could use your fingers to help you. 57, 58, 59, 60, 61, 62, 63. I have a remainder of 7. Okay, now we're thinking 8 into 75. So how many times does 8 go into 75? Let's have a look down our multiples to help us. 1, oh, how close can we get first of all? Oh, 80 too far, that's past 75. So 72 is as close as I can get. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. 8 goes into 75 9 times exactly. Sorry, I should have done that in blue as not to confuse you. There we go. 8 into 75 goes 9 exactly. And how many remainders have I got this time? Let's count on from 72, 73, 74, 75. We've got remainder 3. Okay, so now I want to do 32 divided by 8, or how many times does 8 go into 32? Let's have a look. 8, 16, 24, 32. Fantastic. 8 goes into 32 4 times exactly with no remainders. So hopefully year 6, that's helped you feel a little bit more confident with those. What's the final step then that we need to do? That's right, well remembered, we've got to put that decimal point in. If your answer has 2 decimal places after the decimal point, if your question has 2 decimal places after the decimal point, so will your answer. Okay, that leads us on to number 5 then. I've written it out down here. Now, you've got several calculation symbols in here. So straight away, you'll notice we've got 24 divided by brackets, 6 subtract 3, bracket, multiplied by 2. That means we've got to use BODMAS to help us. And hopefully you've remembered that from last week or earlier this week, I think, I can't quite remember. So B stands for brackets, O stands for other, which when we were at primary school could be squared or cubed numbers. When you go to secondary school, you'll have other calculations you'll be able to add in for that one. D stands for division, M stands for multiplication, A stands for addition, and S stands for subtraction. So the first thing we have to do is see if there are any brackets in the question. We've got brackets here, 6 subtract 3. So I have to do that calculation first. And 6 subtract 3 is 3. I'm going to jot that down so I don't forget. Okay, we've done the brackets. Let's have a look. Are there any squared or cube numbers? No, not in this calculation. Are there anything I need to divide, any division? Yes, there is. 24 divided by 3. So I'm going to do a jotting. Jotting is always really useful in case you think you've made a mistake. You can go back and check really easily. So 24 divided by 3 is 8. I know my 3 times table. 3, 6, 9, 12. I can count on to 24 to know it is 8. Okay, I've done the division. That leaves me next up with multiplication. So do I need to do any multiplication? Yes, I do. I've got to multiply by 2. So I've got to do 8 multiplied by 2, which is 16. I know my 8 times table, I know my 2 times table. 8 multiplied by 2 is 16. So my answer to this question is 16. Okay, I've done the multiplication. There was no addition. I'm just going to double check. And the subtraction was inside the brackets, which I did first. So I can be confident that I've got that answer correct. Right, let's have a look at our flashback for today then. This is sort of our revision section. We've got to calculate 864 divided by 4. So I've got my bus stop method ready. And I'm going to use my 4 times table for this one if I need to. I can write it out on a bit of paper in my exercise book. Okay, and so on. Okay, so I could carry on if I need to. Right, 8 into 4 goes twice. 4 into 6 goes once. And with how many remainders? 2. And 4 into 24 goes 6 times, 216. Okay, we're going to go straight on to question 2 then. We've got 3,416 subtract 2,006. Now, I think lots of you could do this mentally. Let's find some space to do a jotting. I'm going to get rid of this one for a moment. So I've got 3,416 And the first thing I'm going to notice here is that I can subtract 2,000 really easily. Okay, I know how to do that. I'm just looking at that thousands column. 3,000 subtract 2,000. What would I have left? Well done, everybody. 1,416. Okay, and that leaves me with 6 to subtract. Well, actually, if I look at this number, I've got 6 in the ones here. So I can subtract 6 really easily. 1,410. There we are. Oh, let's make sure that looks like a 0. There we go, 1,410. Okay, next question then is question 3. So we need to round 145 to the nearest 10. So I've got my number here ready to go. If I'm rounding to the nearest 10, I need to identify which digit represents the tens. So which digit is it, year 6? Which one represents the tens? You're absolutely right. 4 represents the tens. And then I can look next door. 5, 6, 7, 8 or 9 means I round up to the next 10. So the next 10 after 40 is 50. All digits before stay the same and all digits after become a 0. Now some people like to think about this as if it's on a number line. So if I've got 145, what's the 10 that comes before? The multiple of 10? 140. Next multiple of 10 is 150. And we would round up to 150. It's closer to 150. Okay, right, we're going to have a look at this angle question now. We haven't done a huge amount of angles work this year. We've done some sort of revision, haven't we, in the afternoons as we're going home. So for some of us, this question might have been a bit puzzling at home, and that's okay. We're going to have a look at it together now. So we want to know, does the angle measure 125 degrees? So as you can see, the blue lines and the red line here, this red part represents the angle that we're measuring. So we want to know how big this space is in here. So they've put the protractor, they've found 0, and they've put 0 on the base of the angle here. And then we follow 0 round to measure the angle. So we go 10, 20, 30, 40, 50. Now it's gone past the 50, but it's not quite at 60. Now I would suggest that's about halfway. So we know that halfway between 50 and 60 would be 55. So this angle measures 55 degrees. So does the angle measure 125 degrees? No. Now, year 6, I've got a challenge for you, for those of you who like to be stretched with your learning. I wonder if when you send me your work, could you explain the mistake that this person has made? Because if you follow this line up, we measured up to here, didn't we? Now, if I follow this line up, it does look as if it becomes between 120 and 130. So what mistake has that person made, potentially? Okay, I'm really looking forward to seeing your answers. Don't forget to share them with me on Class Dojo. Have a lovely day, everybody.